Hey guys, today we're going to learn how to solve absolute value inequalities graphically and algebraically. So first we're going to start with graphing. Now I put steps here for you to follow. First, just like how we solve absolute value equations graphically, we always do the same thing even with inequalities. We're going to graph each function separately on the same coordinate plane. So what that means is that you're going to graph the absolute value part using transformations first, and then you would graph that horizontal line, such like in this example where it's greater than 4, we would draw that horizontal line at y is equal to 4. Now, if your inequality is greater than, that means that you want to find the x values for which the graph of f of x, your absolute value, is above the line. And for when it's less than, we look when the absolute value is below the line. So here I have already the graph for the absolute value of x plus 3 plus 1. You can see from the absolute value equation that my absolute value was moved to the left 3 and up 1. And then it's greater than 4, meaning that we have that horizontal line at y is equal to 4. Now our solutions start for where it intersects, which is here and here. And since we're looking for when it's greater than, that means that I have to look at for when it's above the line, which are these two sections right here. Now, when we're writing our solution, okay, the solution is sometimes easier if you were to put it on a number line. We have to look at those two x values where it intersects. So at -6 and at 0. These numbers would not be included, and that's because it's greater than, not greater than or equal to. So I would use an open circle. And as you can see, the arrows and the part that I've highlighted, it's going to the left and then it's going to the right. So we would shade the left side and the right side. So now when you're writing your solutions, instead of x equaling a number, it's going to be an inequality. So for example, this first section here, this is for when x is less than -6, and that's because to the left of -6, it is less than. And we also have for when x is greater than 0, because it's to the right of 0. Now because these are two separate intervals, right, our solutions mean that x is either less than -6 or x is greater than 0. And that would be our solution. Now let's try this out, but from scratch. So we have in this first one, the absolute value of x minus 2 minus 3 is less than 1. So just like we always do with our transformations, we're going to write the rule that we would use in order to graph this function. And the rule would be x plus 2, because remember you always do the opposite with what's inside with the x, y minus 3. Our reference points are -1, 1, 0, 0, and 1, 1. So now we plug it into our rule. And for this first point, when we plug in -1, 1, we get 1, -2. When we plug in 0, 0, we get 2, -3. And when we plug in 1, 1, we get 3, -2. So these are my points. I'm going to go ahead and plot this. So 1, -2, 2, -3, and 3, -2. So this is my absolute value. Now we have here that it's less than 1. So I'm going to draw that horizontal line at y is equal to 1. And because it's for when it's less than, that means that we look at the section of the absolute value graph that is below the line. So we see here it is that section there, below. We have to notice those points of intersection, so right here and here. So I'm going to do my number line. Those 2 points are -2 and 6, both of which are not included since the inequality says less than, not less than or equal to. And you can see that it is the middle section of the graph because we have this is the left, this is the middle, and this is the right. So I would shade this section right here. So now when I'm writing my solutions, we would start with x is greater than -2, since from -2 to the right is shaded, so that means greater than. And then we have x is less than 6 because the shaded section is to the left of 6, meaning less than. Now I put here that inequality will be an or statement when there are two separate intervals, such as the one that we looked at before. This, however, is an and statement, and that's because it is one section, one interval of my graph. So that means that the solution has to be both greater than -2 and less than 6. So this would be my solution. Let's look at this next one here. We have the absolute value of x minus 1 minus 4 is greater than or equal to -2. So just like before, I'm going to go ahead and write my rule. The rule for the x's here would be x plus 1, and the rule for the y's would be y minus 4. I'm going to use my same reference points, -1, 1, 0, 0, and 1, 1. And now we're going to go ahead and plug it into the rule. So -1 plus 1 is 0, and 1 minus 4, -3. When I plug in 0, 0, I get 1, -4, and when I plug in 1, 1, 1 plus 1 is 2, and 1 minus 4, -3. So these are my points I'm going to go ahead and plot. We have 0, -3, 1, -4, and 2, -3. So I have my absolute value part graphed, and we see that it's supposed to be greater than or equal to -2. So I'm going to draw that horizontal line here at -2. And because this is for when it's greater than, that means that it is the section above. And we can already see that since I'm highlighting two separate sections, this is going to be an or statement. But we're always going to graph these on a number line. So we have our 2 points of intersection, which are at -1 and 3. Additionally, these points would be included. So I'm going to put a solid circle because it is greater than or equal to. And then we're going to shade everything to the left and to the right, since this is the left side and this is the right side. So now my inequalities. We have x is less than or equal to -1 because it's to the left of -1. Or, since it's a separate section, x is greater than or equal to 3, since it's the section shaded to the right of 3. And that would be my solution set for that inequality. Now let's look at how we would solve these algebraically. Okay, and here are some steps for you. And it always starts off the same way, just like when we solve absolute value equations. We start off by isolating the absolute value part. So in order to do that, I'm going to add 10 to both sides. And I get the absolute value of x plus 4 is less than or equal to 8. Once you're here, you're going to rewrite your absolute value inequality as two inequalities by first removing the absolute value while keeping the same inequality symbol. So my first inequality would be x plus 4 is less than or equal to 8. And then the second inequality, you're going to switch the direction of the inequality and switch the sign. So x plus 4 is greater than or equal to -8. And now we're going to solve each one independently. So for both, I would have to subtract 4. And I get that x is less than or equal to 4, and x is greater than or equal to -12. I have here the number line. Remember when graphing to keep in mind whether you're going to use an open or closed circle. Since these inequalities are less than, greater than, or equal to, those numbers would be included. So 4 is included and -12 is included. Now x is less than or equal to 4. If it's less than, that means it's to the left of 4. And as you can see, that's going to be the middle section here. But you can always check with your second inequality. X has to be greater than or equal to -12. And you can see that the shaded section is greater than -12. So this would be considered an AND statement since it is one section of my number line. So x is less than or equal to 4 and x is greater than or equal to negative 12. So both have to be true for the solution. Let's try a couple more examples. This first one, we're going to divide the 3 to get the absolute value part alone. So absolute value of x minus 7 is greater than or equal to 3. Now that the absolute value part is alone, I can write my two separate inequalities. So x minus 7 is greater than or equal to 3, and x minus 7 is less than or equal to negative 3. For both, I'd have to add the 7. And I get that x is greater than or equal to 10, as well as x is less than or equal to 4. Since these are equal to, these numbers would be included, so 4 is included, as well as 10. X is greater than or equal to 10, that means I would shade to the right. And x is less than or equal to 4, that means I would shade to the left. So this is an OR situation. So this would be my solution. X could either be greater than or equal to 10, or x is less than or equal to 4. For this last one here, we're going to subtract the 15 to get the absolute value part alone. And we get the absolute value of 4 minus x is greater than negative 1. Now, just like with absolute value equations, if you have an inequality that's set to either greater than or less than a negative number, you have to look at that inequality as a whole and determine what it means. Absolute value is always positive. So if it's always positive, that means it's always going to be greater than negative 1. Doesn't matter what x value I plug into here, it's always going to be greater than negative 1. So if that's the case, this is all real numbers. So you would shade your entire number line. Just to kind of clarify with that a little bit, let's look at some other examples. So with our absolute value equations, there are 3 possible types of solutions. You either have 2 solutions, 1 solution, or no solution. With inequalities, we either have 2 inequality solutions, all real numbers, or no solution. And that's because of absolute value. Since absolute value is always positive, it's always going to be greater than a negative, which is why in that previous example, we got all real numbers. But if we get that the absolute value is less than a negative number, then there is no solution because absolute value is always positive. It will never be less than a negative. So let's evaluate with these 2 examples. In this first one, I would have to subtract the 5. No matter what, your first step is always to isolate the absolute value part. The only thing is that you would have to then evaluate your inequality if it's set to a negative number. But if it's positive, you follow the same steps that we did before. Now here I'm going to divide the negative 2. And when you divide or multiply by a negative, not just when you multiply and divide, you have to multiply or divide by a negative number, then that means that your inequality symbol changes direction. So now my inequality is absolute value of x minus 7 is greater than or equal to negative 2. Remember, absolute value, it's greater than a negative, meaning it'll always be positive. So this is another one of those where it is all real numbers as your solution. And we would shade the entire number line. Now in this next one here, we have 6 minus the absolute value of 3x minus 2 is greater than 12. So I'm going to start off by subtracting the 6. Since the 6 is positive, we have this negative still. Absolute value of 3x minus 2 is greater than 6. Now to get rid of this negative, I'm going to have to divide by a negative number. Now since I am dividing, remember that that means that I am going to switch the inequality direction. So instead of greater than, it's going to be less than negative 6. Absolute value will never be less than a negative number since it's always positive. So this is no solution. And when it comes to the number line, you would just leave it blank. And this is solving absolute value inequalities.